And it's been years since the Transformer came out. GPT took the decoder part, and there were some modifications like Llama really popularized group query attention to make the attention more efficient. Then there was Mistral with sliding window attention to better deal with longer contexts. There was a multi-head latent attention from DeepSeek to cut down on the compute cost. And so Mamba, a state space model, the motivation was trying something different to reduce the quadratic cost of attention mechanisms. But the goal is always to find the sweet spot. How much access to the input sequence do I actually need?
Welcome to AI Catch Up, the podcast catching up with the tech products that matter in the AI era.
Hi everyone, welcome to the AI Catch Up. In the podcast, we are looking deeply into what is happening on the backgrounds of AI. And today, my pleasure is to have Sebastian Raschka on our podcast. And he's the person that has achieved something incredible in the machine learning space. He's currently standing in the ranks with the long-time machine learning practitioners, such as Andrei Karpathy with his YouTube series, or Andrew with his legendary Coursera course. Through his book, Built a Large Language Model from Scratch, that I'm having on my table as my handbook. He has helped countless people to finally get their aha moment in understanding how LLMs work. Sebastian, welcome to the show.
Yeah, thank you for the kind introduction, Elina, and thank you for the invitation. I'm happy to chat all about AI, large language models, and everything else you might find interesting. And in your introduction, you mentioned Andrei Karpathy and Andrew Ng. I must say, I'm flattered. I'm not sure if I'm quite on that level, but Andrew Ng was a big inspiration for me when I started. That was like, I was in grad school 2011, 2012-ish. I took his course, the machine learning class on Coursera. And I think he also had a Stanford one I watched that was on YouTube, I think. And it was a big inspiration. I had the pleasure to meet him at the conference once at CVPR. And, was one of my biggest moments of my career because it's basically the person who started my career. So thanks for mentioning me in the same sentence as Andrew Ng, even though I think he's on a very different level, but I'm quite flattered.
Well, now I would actually challenge you a bit, if you don't mind. And I'm pretty sure that you have heard that question, and actually not once. But if you would be currently starting completely from scratch, how would you actually learn AI? That probably has been for you already around 13 years that you're in the field. If we are doing something like that in the current times, it would be different. But I would be curious to hear your opinion. What would you recommend to someone that is listening and is willing to get the first introduction and then also be able to apply AI to certain projects of his or hers?
Yeah, I think that's an interesting question. I think I would definitely start differently compared to how I started. So back then I got into the field via detours. I took a class in statistical pattern classification back then, which was more focused on Bayesian methods, statistics and stuff. And then I got into AI from there. I think there are infinite ways to get into AI. There are a lot of books and courses and everything's out there. I think you find a million ways to get into AI. I think one of the most important things is these days to stay focused because there are so many resources out there. And I think it's easy to get distracted where you start with one resource and then you don't finish it and go to the next resource. And I think that is where there's almost too much out there where it's tempting. I think it's good to switch if you notice that one resource doesn't work for you, because then, eventually you have to try something different. But I think otherwise, keeping focused, I think, is important. And also, but one thing I think that helped me a lot, and I would also still recommend that, is to pick a project, like something you find interesting, where you can apply the things you learn. Back then, for me, it was a bit weird, but I was into, I still am a soccer fan. And there was this, it's called Daily Fantasy Sports. There were like these leagues online where you could participate to predict which player plays well in the real world, and then you get points and stuff. And so my goal was kind of automating that. So one was basically with programming, like automatically scraping the web to find out who is injured and who's playing and whatnot. And the other one was basically optimizing the team because you had a certain budget, and then basically predicting who's going to score, who's going to get how many points. And I learned ML, and then I kind of also try to always incorporate these things into my project. So this was like not a university project, that was a side project at university. I worked on ML for computational biology. But the big picture is really, I think, getting excited about it, working on something, and then learning tools that kind of help you with the project, because I think that's the way you keep motivated. Otherwise, yeah, you will just learn things, you will never use them, and maybe get bored. And I think that's so mathematics or statistics, or the foundations, I think they're also still very important. um, so, I mean, there are different types of learners. Some people start bottom up, like learning, let's say, the fundamentals first and then applying them later. Or there are people who are just applying things. I mean, so many libraries out there that make that easy, and then learning about the fundamentals. I think either way works. But yeah, what I'm trying to say is also these fundamentals, I think they still remain important. So you eventually understand how things work. But then coming back to the thing I mentioned about the project, if you just want to get into AI or machine learning and you start with math textbooks, like, oh, I need to learn calculus, linear algebra, statistics, and so forth. If you start with these textbooks, they're amazing, but you would probably lose the motivation at some point, because I mean, no offense, but they are relatively, if you want to get into AI, they're relatively dry in a sense, because they don't talk about AI, right? They are just math textbooks. And then you have like this 800-page math textbook, and 2 years later, maybe you finish it. And then at that point, I think you would just drop it and just do something else. So finding a balance is also important. Like, yeah, learn some fundamentals, but also do some things that you enjoy if you are planning to work in AI. I'm not saying people don't enjoy math. I'm just saying if you want to learn AI, these math textbooks, they are supplementary resources. They're very important, but I think I would mix it. So in a sense, I earlier mentioned stick with one resource. That's still true, but also finding the mix between working on projects and learning theory. Long story short, but that's maybe how I would recommend approaching things. And the other one is also with AI, things change constantly. So there are so many things you have to keep up with. And what I do is personally, I still do that. I keep lists of interesting blog posts, books, courses, things I want to check out. But instead of checking them out immediately, also papers, I usually just write it down, and then I set aside a certain time, usually in the morning or in the evenings, like an hour or two in the morning, to do some reading, and I pick from the list basically. And often I wrote something down like 2 weeks ago, and I go through my list. Oh, this was actually interesting at the time, but the world moved on. I don't need to read that. I can focus on something else. Like, being protective of your time is also important, to not get sidetracked with things that are important or interesting today but may not be relevant in 2 weeks. So like, really, I think today it's more important than ever to really manage your time well if you want to get into AI, because otherwise there's always something new to learn, and it's really important to have a plan almost.
I can see your points in terms of first, well, being curious and at the same time having a certain target ahead. That is the potential project that you will be happy to complete. And at the same time, what is also very interesting to me, and I would definitely try that as well, is indeed to recover the practice of what I was previously always doing, bookmarking things. But at the same time, probably allocating the time in a day where I know that, well, it is a good time for reading, and that is the good time for, reviewing especially long form content that is in the form of longer articles. That would be definitely helpful to me, and I'm pretty sure for listeners as well.
There's one more thing I wanted to mention, and a lot of people ask me in general often what tools I use and everything. And I think here, when you do this, it doesn't really matter. I would not overthink it. It's like, just keep a list in Google Docs or on your computer in a text file, Markdown. It really is not that important what tools you use. That's like over optimizing. It's really just the habit, like you said, just setting the habit. And I think that's what matters in the end. Tools are just tools, and there are always other tools. People sometimes ask me also for tools that I use for making figures. And the boring answer is I just use my presentation software, Apple Keynote, the free software on my Mac, and it works.
Yeah.
It's like, yeah, sometimes the simple things get things done. It's more of the habit, more about the habit of doing things rather than the tool often.
I should be very grateful to you right now for actually crossing out this whole idea of optimizing my approach to reading and learning about things, because I'm the person who is having the idea of, yes, let me create this second digital brain of mine, let me throw things into Notion, let me maybe classify things around and then bring them as reminders to me at certain point based on certain graphs that would be there. And yeah, that is definitely good to have that now not anymore in my to-do list, because it is very true. The simplest things are the best ones. I would be, though, also now that you have mentioned your reading time, be interested in understanding how to approach the particular type of literature, namely scientific papers. And, well, it would be difficult to find the literature that is having this level of dryness in it. Again, it is the goal of the scientific paper to describe it as succinctly as possible, and also not having certain emotional additions that would be helpful for reading. But how do you actually cope with the whole flood of papers that are currently coming up in our field? And how do you keep track of those things? And at the same time, how do you take the important highlights for yourself out? Is there something that we can learn from you there?
Yeah, that's a good question. It's almost like related to what I mentioned earlier, where you have a motivation why you read those papers. And so, I mean, keeping up with things is a motivation itself, but well, then there's still an infinite amount of papers, and you can make it a full-time job to just read papers. I used to be a moderator on Archive for the machine learning category, where it was basically our job as moderators to scan the new submissions. You were just reading the titles of the papers, but still, it took hours sometimes. And in the same way, if you just want to keep up, it could be just a full-time job. So personally, how I read papers is I usually have a goal why I read those papers. So the same thing goes for note taking. I used to take notes about everything. I was reading a paper and was just writing or summarizing everything. And this is not super effective at the end of the day because I never really used these notes. Maybe they sometimes help you think, but having general notes, I think, is usually not very useful to me in the end. Usually, nowadays, how I read papers is I want something particular from them. So to make this more concrete, so right now while we are recording this, so I think the article is hopefully out when this podcast goes live. But right now I'm interested in following up on my previous article on reasoning models. So I'm just going through this. Maybe this helps explain how I read papers. So I wrote this article about reasoning models, and I categorized them into 4 categories. There was like inference time scaling, pure reinforcement learning with supervised fine tuning, like the more traditional way, and then also just pure supervised fine tuning, or nowadays people call it distillation. And distillation used to be something different, but supervised fine-tuning distillation in the context of reasoning models is often nowadays the same thing. And so I have these 4 categories, and I want to follow up now on this article with the recent research in each of these areas. So what I did is I have a list of all the reasoning papers I found on Archive in the last 2 months. It's actually, more to be precise, since January 22nd, which is when DeepSeek came out, because I wanted to cover now the articles that came after. And so I just have this list, and then I did a first pass and like which of all these papers are actually interesting based on the title and the abstract. And then, these are reasoning papers. And then I started categorizing them into these 4 categories. It's not always possible because sometimes they do both inference time scaling and reinforcement learning, because that's what you do in practice. But I'm more interested in what technique did they use there. So I have like this mindset where I want to understand what is new, what have they tried, and what is different from what other people do. And so I have like this big picture view. So I have like these 4 categories, and I literally just downloaded the PDFs and put them into 4 folders for each category. And I do have an e-reader because reading on the computer, I'm easily distracted. Is email, there's social media. I tried all the things. I tried to log out, and I tried to make a second account, and in the end, I always get back to somehow browsing the web. And so what I do is usually I just send them to my e-reader, which is an offline. I mean, it has an internet connection to download the papers, but it doesn't have a web browser or anything. So it's just reading papers, PDFs, and then I just read. And when I take the notes, how I take notes is with my question in mind. So if I read these inference scaling papers, I just only take notes on the part, what did they do about the inference scaling? I don't take notes about other things that are not relevant to this part, basically. Sometimes I find interesting things, I circle them and make a note. I'll follow up on that later. But what I'm trying to say is I'm trying to read things with a goal in mind instead of just generally reading. Sometimes I get ideas or I find something that is interesting. But I wouldn't nowadays almost read papers for the sake of reading papers. There's usually a topic that is associated to it. Like, I want to understand reasoning models, so I read reasoning models papers. And I honestly, today, I almost read no computer vision papers. I used to read a lot of them because I was working on projects related to computer vision, but it changes. And so in that sense, Yeah, that's how I approach things. I wouldn't say that's right or wrong, but I think if you are interested in learning about general methods, it's almost always more effective to learn from a textbook. There's usually textbooks are like 1 or 2 years old, like behind the research papers, but they are also always more like well polished, and they focus on the methods that actually work and are useful and used in practice. So I think learning is best with still textbooks because they have the information really extracted, where a paper has a lot of fluff, that things that work and don't work, and papers are more like the latest on a certain project you're working on. Like, so if you are trying to get into AI, I think textbooks, courses, and then with papers, if you're working on a project, to get the updates or new things you want to try based on the foundations that are built on textbooks and courses. Long story short, personally, how I read papers nowadays is very targeted based on the project. And you mentioned something interesting. You mentioned building this digital brain, right? So you mentioned like Notion and stuff. I never really got into that, but what I did is not too long ago, maybe 5 years ago, I was building something like my personal Wikipedia page. Basically, it was only for me. It was on the internet, so I could log in from the phone or from any computer. And I spent a lot of time building this. And in the end, today I don't use it. I spend a lot of time and work on doing that. And I don't know. So in that sense, yeah, I think I wouldn't overthink it or optimize it. If you read papers, yeah, I think it makes sense to take notes, but I wouldn't take notes about everything, because usually I read these papers, I took notes, then later on I had a question about something. I was working on something that I read 2 years ago. Honestly, I didn't really read my notes. I just went back to that paper and read the section in the paper, So it's like, yeah, you can spend too much time on taking notes almost. Yeah.
Yeah, understandable. And that is probably why I will be also not building the digital brain for me so far, without having the clear purpose for the digital brain. I can keep you updated on whether I've found my purpose for that. You have mentioned reasoning models, and it seems to be the very strong research priority for you now. What fascinates you in those models? That is probably that in 2025, I'm pretty sure will remain one of the main things that we observe in the field. Well, and deep research in a way. But with reasoning models, it is extremely impressive from the perspective on, again, switching the established approaches to how we are doing things. But do you see something particular that we should think about when it comes to practical applications with reasoning models?
So it's an interesting question. The reason why I'm, no pun intended, interested in reasoning models is that they are the next stage almost. They are more capable in certain things. The one problem with them is they are expensive, more expensive than regular models. So then if you just have a question that is who's the first president of the, I don't know, United States, you don't need a reasoning model. You can just have a model. If it had it in the training data, it can look it up. Maybe in this case, LLMs, they're prone to making up information. You could also even just go to traditional search. So for simple queries, reasoning models are not necessarily efficient. They cost more money usually. But for me, why I find them useful and interesting is because they help me solve problems I can't solve myself sometimes. With these simple questions, I can also just use my traditional search engine and find out the information relatively quickly. Or other things. It's maybe a trivial example, but if I have a math problem, LLMs can do function calling. I can ask it, I don't know, simple question like, what is 23 times 123? I don't need an LLM for that. I can use a calculator. LLMs are not that useful for me in that context. You can use them for grammar and stuff like that, but you can also use other tools. But with reasoning models, I feel like that is like a thing that you can't easily do otherwise. You can do it yourself. You can think about a problem. But what I find actually really cool and useful is, especially for code and math problems, where I can ask it, hey, can you see any issues with my code here, and explain why, and where you get more value out of it. It's not telling you what's wrong and what to try. It tells you why and how. And that is honestly, I feel like I'm learning almost from there, where it's explaining something to me and I learn, I become smarter by using them. Because with regular LLMs, it's almost dangerous. You use them and you feel like, well, you get lazy, you honestly get worse at things because you just let the LLM do everything. You can have the same issues still with reasoning LLMs, if you don't read the responses, you don't learn anything. You just take the answer, and then at some point, if you have it write all your code, you probably will become worse at coding. But if you actually write your own code and you ask it to improve the code, you read the suggestions, you try them out, it's actually really cool. It's like a study partner almost. And it helps. And they are also at certain tasks more capable, because through this intermediate thinking, reasoning trace, the LLMs also have more compute that helps them get to the correct answer. So there are multiple strategies. One is creating more answers and then having a verifier selecting the correct answer. So that is one way where you just get more correct answers on harder problems, because you spend more time on. It's almost like majority voting, or having an ensemble of experts. You create multiple solutions, and then you have someone else checking the solutions and selecting it. And so in this case, someone else would be another LLM. But verifying solutions is actually easier than generating them. So that is usually a relatively small LLM. But then, of course, the reinforcement learning and everything, there are a lot of techniques to improve reasoning. I just find that interesting, because there are so many different approaches. And it's currently this time where people are trying out different things. And it's really exciting to see what works and what helps. And what's nice is also these different things can all be combined. And I mentioned earlier, 5 minutes ago, that reasoning models are not good at simple things. But one interesting trend especially is people are releasing LLMs where you can turn the thinking on and off. Like, where, for example, there was just top of my head, like IBM Granite, Claude, Sonnet 3.7 was released. I think Grok has a thinking button. They all have like that feature now that it's one LLM and you can use the thinking or not thinking. So that is something we are moving towards in 2025, where it's just reasoning is just like a level up for LLMs, essentially. That's why I find them interesting. I find LLMs interesting, and these reasoning models are taking them to the next stage, essentially.
I think that is a good mental model to think that, well, if I am having the task where I might require a sparring partner that would walk me through the steps and ideas on how to solve a particular problem, then to go for a reasoning model could be a good idea. What I'm also thinking about, and I can also see what you are describing in terms of switching between approaches when it comes to what way of using LLM would like to do. It is within the power of users if we can switch on and off, right? But if I'm thinking about creating an application, let's take an example, that would be the common thing, helping me on planning the travel. Would you expect that the best application in the field would be using reasoning or won't? Will it be reasoning that would be turned on by the application developers, or will it be on the side of the users? Do you have a feeling towards how that will be getting traction?
Yeah, that is a good and tricky question. So I also would say, well, there are these dedicated reasoning models. OpenAI O1, it's like specifically termed reasoning model. And as a rule of thumb, someone says, or in general, the definition goes that reasoning models have these intermediate steps. They have generated longer outputs and so forth. But I would say, looking at the first generation of LLMs, like, GPT 3.5 and now GPT 4, and I'm also saying GPT and ChatGPT, but, it can also consider other things like Gemini and Anthropic. I'm just using one of them for simplicity. But I feel like they have also become better and sometimes generate longer answers if you ask them and stuff like that. So they have like these, sometimes even like the simple model has intermediate steps. And that is because also the training data, it depends really on what the training data looks like and what the prompt looks like, the system prompt and stuff like that. There was classic chain of thought 2 or 3 years ago where people appended the phrase think step by step, and then it was generating the reasoning trace. And it's not such a binary decision, like this is a reasoning model and this is not a reasoning model. So all models nowadays, I feel like, are capable of some reasoning if you prompt them or have a correct system prompt and so forth. And with your traveling example, I think you can get relatively good answers if you just ask a regular LLM, even maybe GPT-4. Can you suggest a travel plan for me? Like, I'm going to Japan, and what cities should I visit and why? And so I think you probably should get pretty good results doing that. I don't know if a specific reasoning model would help. It depends really what type of reasoning model. R1, for the other ones, we don't really know for sure because they don't really share the details. But for DeepSeek R1, they specifically trained this on math and code for reasoning. So they had like the reinforcement learning pipeline where they had a verifier for math and coding questions, and then the LLM learned to generate these intermediate steps to better get the correct solution. The reinforcement learning reward was just like, is this basically correct or not? Does the code compile or not? And then the LLM just figured out, oh, if I generate more intermediate steps, it often leads to the more correct answers. It's like a trial by error. It's almost like we humans, when we solve a math problem, we don't do it all in our head and just give the final answer. Usually write it down step by step. And I think for that part, because it's mostly trained on math and code, for the traveling, it wouldn't really help. The other thing you brought up with the traveling, it makes me think of these travel agents, which is basically like agents is another big hot topic in LLM land in 2025, where people are developing these agents where it's more like interacting with the environment in multi-step. And I think this will be interesting to see also, because I think what's almost missing is I think people are working on that, but like a router that delegates a user's task. When you have these general chatbot LLMs, right now you have to select your LLM. Like, again, I'm just saying OpenAI ChatGPT because it's a popular example, but other companies have that too. There's a drop-down menu, and you have to select, oh, I want that cheap LLM because maybe I don't need something complex. I just need something simple, like, fixing grammar errors. So I can use that cheap LLM. Now I want to have reasoning, so I select the different model. And now I want deep research, and then there's this button you have to click for deep research, or the button you have to click for web search. And then I think people have also these agent things. I think deep research is kind of like an agent where it goes, searches the web, uses some tools, and compiles things. And I think it's a lot of work on the user where you have to choose what you currently need. I think what's interesting is how to have the LLM decide. So it could be still separate LLMs to be cost effective, but then you have a router that intercepts your prompt and routes it to the correct thing, basically. So in that sense, like for the traveling, I can imagine like the first iteration, you just need a simple LLM that suggests I don't know, travel plan to Japan, like what are the steps? It's just a very simple list. But then if you have questions like, do I need to apply for XYZ? Then you maybe have some other LLM that searches actually the latest information on, let's say, the government website and crawls the information and summarizes it for you. So it's a interesting problem where, you have like an interplay between different kinds of LLMs. And you need different LLMs, different skills almost. It's not like a one size fits all. I mean, you could, but this would not be very efficient. It would be very expensive to train one LLM that does everything.
Probably we can also then lose on deterministic nature that we could in theory define through smaller LLMs. So meaning that if we know that we really need to check for the requirements for visa, using smaller LLM would help us achieve the goal that, well, the call about visa application would be happening, whatever will happen. Yes, the response is not something that we can define, but at least this task would be done.
Yeah, and sometimes, so certain parts you maybe don't even want a summary. You really want to literally query the official website and extract information. And so recognizing when you need which basically is also interesting. So you can ask the LLM, please quote from the website or something like that. But the queries can be complex and the interaction will be interesting, how even within a certain dialogue, the LLM learns how to delegate to other LLMs, not trying to brute force come up with a solution itself. And I think that's where agents are useful. People use the term agents for having something like booking your travel with your credit card, but I think even simpler, it's really just using different LLMs to get different information differently, for using or leveraging the strengths of the different LLMs.
Yeah, one of the questions that is actually something that I have been not thinking of on my own, but I have asked the community of AI trailblazers that I'm running on whether there is something specific that they would like to ask you. And the most upvoted question was actually, what's your view on the future with regards to model architectures? And the particular example that was brought up was with regards to Google Titan models. And so we have discussed right now, okay, there are agents, there are potentially the combinations of LLMs. Do you think that in the near future we will be maybe even switching from GPT per se? We will be maybe going back to some autoencoding approaches, or maybe we will be doing something that researchers have predicted last year to be a big thing, namely Mamba. At the same
Yeah.
time, I still don't see that coming. So,
Yeah.
do you think Transformers are with us in the current form for some time?
Well, this is a very interesting question. I don't want to be giving a definitive yes or no answer because I think I'm just speculating here. So everything I say, please take it with a grain of salt. But yeah, like you said, there was Mamba, and that the multiple goals here. The one why people are working on those. The one thing is GPT is based on the transformer architecture, which came out maybe 2016, 15, 16, or 17. I know GPT, the first paper came out 2018, so it was 1 or 2 years before that. And it's been, when we are recording this, it's like 7 years ago, like since the Transformer came out, and people are still using it. That doesn't mean really the transformer hasn't changed. I mean, the transformer architecture. GPT took the decoder part, and then there were some modifications. Like Llama really popularized group query attention to make the attention more efficient. Then there was Mistral with sliding window attention to better deal with longer contexts. There was a multi-head latent attention from DeepSeek recently, also to cut down on the compute cost. There are other, I mean, not in the attention mechanism, but there are other modifications like a mixture of experts to make inference cheaper. So people keep modifying the architecture in a sense to make it more efficient, essentially, like getting cheaper, but also scaling to longer contexts. And so Mamba, a state space model, the motivation was essentially trying something different to reduce the quadratic cost of attention mechanisms and also to work with longer context. Yeah, state space models, when I remember correctly, they were originally developed in the context of DNA sequences, where DNA sequences are also letters, essentially. Like there are 4 different letters that you can have in a DNA strand. And so you have these million long strings. And so the motivation was how you can work with these longer sequences. But then people realized the regular Mamba state space models, they have also limitations with so one of the strengths of attention is really that you have the context of the whole sequence, and then you have the model decide which part of the context it actually needs and uses, and you can artificially restrict that to smaller chunks, but then you might lose information. But the goal is always like to find the sweet spot. How much access to the input sequence do I actually need while keeping the cost low? Because it's a trade-off. It's like trying to find the sweet spot, considering all the information, the most expensive way, and considering only the smallest window, which is the cheapest way. But what is the sweet spot in the middle? And I feel like I've seen recently, like state space model. I haven't been following them very closely, but I feel like I've seen them moving more into the direction of transformers, where they have more like attention modules now. Top of my head, I think there's Samba and Jamba where they did something like that. And Titan is like a different approach. So they have to deal with long contexts. They do have like memory modules. So I think they had 2 or 3 memory modules. So the paper came out, I think, last year. So it's a bit vague now in my head, but they had like memory modules, and what they were trying to do is during inference to selectively memorize parts of the long context input and then refer back to it and stuff like that. And I think they used optimization to optimize that memory. So the bigger picture here is like the how can we deal with longer sequences more efficiently, like alternatives to the traditional transformer paradigm. But whether they end up being useful or not, that is an interesting question. I think this was your original question. Are these architectures going to be relevant? And I do think to some extent state space models are very popular. I mean, within a certain research subfield, but they haven't really made it applications yet, like these big applications like, Claude, ChatGPT, Gemini, and so forth, as far as I know, because they don't share that much information anymore. But as far as I know, all the big applications are transformer based. And it remains to be seen, because that's like the dilemma, because people working on these methods are very smart people, but they don't have these compute resources, and they don't necessarily develop it for millions of customers. So in that sense, we don't really know how well they work for different real world applications. With real world application here, I mean like ChatGPT, chatbot applications, code assistants, and answering questions and stuff. The benchmarks on the small scale, they look very promising in my opinion. But there are 2 things about it. First, they are just benchmarks. They're more like automated benchmarks. It's hard to say how well these models perform in real life, because nowadays I think people still use benchmarks when they announce new models, but there's this whole culture of vibe. People call it vibe, VIBE, how good the model feels almost. And I think with these other models, personally, I have not really, as my chatbot, I used a state space model, or I don't think even Titan shared their model. So it's hard to say how well they do in real life, in real applications, besides benchmarks. And the other one is they tested them on the smaller scale. For Google Titan, I don't exactly remember, but I think it was below 1 billion parameters. And the results looked super promising, but how well does it scale? Like, what I'm saying is maybe the 1 billion transformer that it is compared to is not a good comparison, because maybe transformers are exponentially worse at that small scale. If you compare them on the 70 billion or 400 billion scale, maybe that's where you see the real difference. And the reason why I'm saying that is also, for example, for DeepSeek R1, when they tried the reinforcement learning, they noticed, for example, the reinforcement learning didn't do very well on smaller models. So that's why they used the distillation on the smaller models. So I think there's a certain thing about transformers where they have interesting behavior at scale if you scale them up. And I wonder how that is for these other models, state space models. Like, maybe the performance saturates at a certain point. So maybe at 1 billion, 7 billion, you get a good performance, and that is maybe better than the 7 billion transformer performance. But what happens afterwards? What happens when you want to go beyond that? And I think that's not answered yet. That's not clear. So someone would have to spend a lot of money to find out. And so then we will know whether they are actually promising. But that being said, I do think there are interesting applications for those models. DNA sequences, for example. In that context, I do think there are promising applications, and I think there's still a good reason to continue developing and trying things out. And honestly, I really like that people are working on them, because you always have to try other things, because otherwise it's not making progress if you just stick with the current thing. And even though I mentioned people are refining the transformer, but it almost feels like cars, where we had gas cars for, I don't know, maybe 100 years. People keep making them better. If you look at the original gas cars, Ford Model T, and then the latest Ferrari or something, it's like very different cars. I mean, built on the same technology or similar concepts. Motors have changed and everything, but fundamentally it's still running on gasoline. And then there's only so far how you can push it. Cars are getting faster, but there's a limit for these cars. At some point, people switch to electric cars, which have other advantages and disadvantages. But it's almost where it's time also to think about alternatives. For the transformer is like this gas car that we keep optimizing to make it better and faster. And it is getting better and faster. Like a Ferrari is better than Model T back then. But I think we hit a certain limit, because I don't know, maybe I'm wrong. I'm not that much into cars, but maybe the current Ferrari is much better than the one 5 years ago, but I think it's saturated almost. And I feel like with Transformers, we are maybe also reaching the point where we are saturating it, and it's time to try out different things.
That was mentioned by Ilya Sutskever, right? Saying, at least from the perspective of bringing more and more parameters to the current architecture, is probably not the approach where we will get higher performance in whatever form we measure it. So then it was very interesting that DeepSeek came out with, we still have something to explore.
Yeah, I mean, this is also interesting, like you said. So I unfortunately I couldn't attend NeurIPS, so I don't know. I think this was a quote from NeurIPS talk that Sutskever gave there. So I honestly haven't had a chance to watch the talk. I don't know if it was online, but when I understood correctly, it was about scaling the pre-training. But maybe correct me if I'm wrong. But what's interesting is also with DeepSeek R1, for example, or DeepSeek R1 is based on DeepSeek version 3. They only used, only in quotation marks, they used 14.8 trillion tokens, which is basically the same that Llama 3 used back in summer 2024. They had 15 trillion tokens. So in that sense, they didn't really use more tokens, but the model is just much better. And so at least, so here, I don't know exactly how much better the V3 base model is than the Llama 3 model, the 405B model, but still the R1 model is much better. And this was mostly achieved with post-training. So I think there's right now also the time where maybe pre-training is saturated, but there's a lot of opportunity and low-hanging fruit still in the post-training. Right now, namely the reasoning post-training, basically. Yeah. So I think there's still a lot of interesting stuff to do there.
And I really like how you're bringing the practical aspects of understanding that, we do have resources that we should be running those models at. The results in the papers can be beautiful and very, very significant. However, in the real world, it would be a bit different, especially when it comes to scaling. And what I would be curious about is that during your work at Lightning AI, you have been looking into multi-GPU environments. What are the things that you have observed, and what are the tips that you might give? And generally speaking, the statistics is definitely that the majority of us are the consumers of the models that have been pre-trained for us. And then we are indeed running inference on them. And then we might be using different GPUs. At the same time, we are almost always constrained with the GPU poor environments, as they call them. Would you say that there are certain things that you have observed that are overlooked when it comes to dealing with the constrained resources of GPUs? And then running, well, mostly inference on them?
In general, one thing I would say, it's not something maybe necessarily an observation, but something I would just give as advice is I wouldn't spend that much time and effort and money on pre-training on single GPU, multi-GPUs, or multi-node in any scenario, because we are fortunate that a lot of companies spend a lot of money on that and then they release the models openly free. So as researchers, we can actually just use those models, the pre-trained models, and build on those. And I think this is awesome. But as individuals, I would say personally, I wouldn't waste or spend money and time on doing it, because even if you spend millions of dollars pre-training a model, this will probably be outdated in a few weeks because someone else did that same thing at a bigger scale better. But of course, some people have to keep doing that. Otherwise, we won't get new models. So I'm actually really thankful that companies are actually doing that and are releasing these models openly. So in that case, we can actually focus more on the post-training. Where the pre-training gets interesting is, and that is a lot of people ask me that, like customers or people I work with, tailoring these models to their domain. So I don't want to name a specific example, but usually it's about specialized domains, just general terms. I don't want to name specific ones, but in that vague specific realm, for example, medical, legal texts, these types of things. And for that, you need some pre-training. So there were also interesting papers. There are, in the compute constrained environments, there were a few really interesting methods that came out. One was LoRa, low rank adaptation. But you can only get so far with that. And they're all ultimately shortcuts, and they have pros and cons. And so with LoRa, for example, I think Dan Biderman had an interesting paper last year on that, where his team looked into getting new knowledge from LoRa versus regular training, like pre-training fine-tuning. And the title of the paper was LoRa learns less but forgets less. And so the thing is always, the more you train a model, the more it also tends to forget the old stuff, which is like the no free lunch. You can't just make everything better all the time. There's something always that has to give, like something that you make worse while you make other things better. And that's like something interesting to keep in mind. So pre-training has become more sophisticated in the last few years. If you consider the recent LLMs by bigger companies who have papers like Llama, Gemini, Phi, Apple Foundation models, what they do is it's like a multi-stage where they have just regular training on filtered data, where data quality is also becoming more important, but they have usually a long context stage where they train specifically on long context data. And that is because a lot of users nowadays, they need to ask questions about the document that they have. So they have a document, they paste it into the LLM and they ask it questions. So the model needs to be better at retrieving relevant information. And so it's a specific stage in pre-training where they optimize for that. And the reason is usually in pre-training, you also don't have that many long quality documents. I mean, there are papers, books and stuff, but you can't just concatenate arbitrary things. It needs to be like a cohesive long document. So it's a specific stage in the pre-training where you focus on that. And then at the end of the pre-training, they usually focus on a high quality annealing stage where they save the high quality data for last. And that is based on the intuition that models tend to forget things that were happening earlier. And so you want to have the highest quality last, because that's basically more present in the model's behavior. In that sense, it's tricky, but it does make sense to train on certain domains. So that is one exception where I feel like, okay, people do need to pre-train on legal, whatever, custom documents and stuff like that. But that is usually not super resource intensive, because these are usually smaller resources. So you mentioned computing platforms. The one challenge is, I would say also for me, for everyone who works on that, is really using multiple nodes. There are tools in PyTorch for that, PyTorch Lightning, PyTorch, that make that easy. But there are a lot of still things and considerations there. There are lots of cloud resources available, but the problem is, usually a lot of people try to train things. So you have limited access to GPUs. You can't just request hundreds of GPUs. And then even if you request them, you have to make sure the connection between them is fast. Considering a simple case, so back in the day, I trained things on a single computer, and that was relatively easy. Even further back, like when I was a student, I trained things on a single GPU, and then I just used multiple GPUs individually for hyperparameter optimization. Right now, this doesn't work anymore. The LLMs fit into a single GPU, but you can't train them because then you exceed the memory. So you need to use multiple GPUs, fully sharded data parallelism, tensor parallelism, and so forth. And that is, requires you to do some extra work. So on the PyTorch front, even if you set that up and it works, you have to make sure the GPUs are connected fast enough, like the connection between the GPUs. For example, that is usually something when you can rent like these AWS L4 GPUs, or I think the A10Gs, you get a server with 8 of them, but they have a very slow connection between them. And so you actually slower training on those than on a single GPU. So if you compare a model that fits on a single GPU and you train it on multiple GPUs, even if you use data parallelism, because the communication between them is so slow that it's actually wasting your time. So you have to make sure you understand a bit about what is this cluster and how does it work. So usually the A100 ones and H100 ones, they are very well connected with NVLink and they're pretty fast. But then you have that server, but at some point you need multiple of those, and then you have this additional overhead, and then you need to understand about Nickel, this NVIDIA communications library, and it's a lot of complexity. And I think that is the main challenge really for people. Let's say I have the GPUs, I have the money, how do I actually train it? And it requires some extra work. But then even as a single person, if you pre-train LLMs, I think you need a team for that. A single person is, unless you never want to go to sleep, because people, they monitor the training runs. They have like apps on their phone. They go to lunch and just stare at the phone and check, is something like, do I have spikes in my loss function? Did my checkpoint crash or something like that? I have to reload the checkpoint, because it's like literally hundreds of thousands of dollars on the line by reserving the GPUs and making sure everything runs. It's a lot of stress. And in a way, it's exciting to train models, but unfortunately that I don't have to train $1 million expensive GPUs, because it's like a lot of responsibility. I think that is one of the biggest things nowadays. Particularly, it sounds easy, but in practice, it requires really a whole team. Llama 3, the paper had an interesting section on that. When I recall correctly, they had like a lot of outages. 70% or 80% of the outages were due to hardware failures on the hardware or GPUs. And so they had to restart the jobs and everything. And that is why, nowadays, when you look at the papers, it's like 100 authors, because you need literally so many people to help making it happen, basically. Yeah, it's not like the good old days where you could train a model on a single GPU. It's more expensive than that and more complicated. But on the other hand, you can do a lot of interesting work on a single GPU. There were also papers when I was like reading the reasoning model updates, or like in general what people have been doing. There were really cool results on distilling models, getting really O1 quality results with like $300 or something, like in GPU costs. It is possible to do really cool work on a smaller scale also still. And I think it's an exciting time. It's interesting to know about pre-training, doing it for educational purposes. For example, in my book, I have a chapter on pre-training, but it's only on a single public domain book, just for seeing what is the loss function, how does it work, what does the LLM optimize, and stuff for understanding. But I wouldn't do it on $1 million scale, because that is a different type of beast. It's interesting and important to understand for educational purposes, but in practice, it's interesting times, I would say.
That is definitely one of the worst feelings ever, when you leave your training job to run overnight, and then you wake up and you think that, now I will get my wonderful results. And then you see that there was a certain problem with it. The worst way to start the day. What I also was curious about, and that is probably something that you have already mentioned, open source and the beauty of people sharing their work with each other and then being able to build on top of the efforts of other teams. When you were working at Lightning AI, you have been interacting a lot with, PyTorch founders. And we all know them as people that have done a lot for open source. At the same time, they are currently running a commercial company. So what have you actually learned on their way of making the contributions to open source work, also taking into account certain commercial interests, maybe certain aspects of how to provide frameworks that work for enterprises. What do you think is something that will indeed help open source also, well, sustain itself?
I think that's a good question because, open source, in a sense, it's free. So how do you sustain that? At the end of the day, at the company, you have people, you have infrastructure, you have costs, right? And how do you balance this with contributing to open source? And I think I would say that not the secret, but the recipe maybe is really to build something you find useful and that helps you with your work. In that sense, Lightning AI is very successful with PyTorch Lightning because PyTorch Lightning is built with a passion like that. Hey, this is actually useful. We need that, and we use that. So, for example, PyTorch Lightning is a library, a wrapper around PyTorch, and so it makes using PyTorch simpler, especially when it comes to what we talked before with the multi-GPU training, because in PyTorch, if you go from single GPU to multi-GPU, it's kind of complicated. You have, for example, FSDP is a lot of lines of code you have to add to make it work. I actually, on my GitHub repository for the large language model from scratch, I do have a bonus material where I do have multi-GPU scripts. And if you do the file diff, you can see it's like 30, 40 lines of code difference to just make it work. And so if you experiment with things, you go from single to multi GPU, it's a lot of extra work. You waste time as a person. If you do it once, well, that's fine. But then you have like hundreds or thousands of people who have to do the same thing, or even you have to do it for different projects, and it's error prone. So with PyTorch Lightning, you basically have a framework where you only have to change a single line of code, where you say, I want 4 GPUs. By default, let's say it uses CDP or FSDP, but it's also, if you want to change that, one string that you have to change. And so in the backend, it's really complicated how that is automatically handled, but you as the user don't have to worry about. And the reason how that is good, let's say in a business or context for the company, why does it make sense to develop that? First, it's really cool to develop it. If people have feedback, well, they use the library, you find bugs, and that makes that better for everyone. And so it's a collaborative thing, it's motivating. But then the other thing is also it makes your own work easier. So when I run experiments, I don't have to write the same code every time. I can just use our own open source library for that. Lightning AI is a compute platform where you can rent GPUs, and you can think of it as a Visual Studio Code environment. There are a lot of additional plugins for multi-GPU, multi-node training, but it saves customers money. So it makes customers more happy because you run your computation. Let's say you try it out on a CPU. The first CPU is free. You can try it out for free. And then you're ready to run things on the GPU. You can just switch in Lightning AI to GPU. And if you use PyTorch Lightning, for example, it will automatically detect the GPU and then automatically run without having to rewrite your code, which saves you money because you don't have to spend 20 minutes of modifying your code. And the same thing if you go from single GPU to multi GPU and multiple nodes, like if you want to run, I don't know, on 400 GPUs. And in that case, it's just better customer experience because Lightning AI, you can use PyTorch and you can also use PyTorch Lightning without Lightning AI, but the combination of the two makes it's like a synergy almost where you get your work done faster, customers have a better experience, but then also people don't have to use Lightning AI. They could also, run it locally, for example, and have suggestions or improvements, and then everyone benefits from this approach, this open source approach. So in that case, I think it's a no-brainer almost to do certain things open source, if that makes sense. Yeah, and it's a lot of fun too. If you've seen my GitHub repository, I do a lot of stuff because it's just fun. It's like addicting almost. Like it's like you have a community, you build things, and it's fun, and you learn a lot also. You basically learn together. I think without open source, I started back then contributing to Scikit-learn. I learned so much by just contributing because there are people who are smarter than you. You do a pull request, they have suggestions, you learn something new, and it's you contribute something they find useful, they give you useful feedback, and it's just like a win-win.
First of all, I follow you on GitHub. That is one of the things how I'm keeping up to date with all the things that you're doing. Another thing that I'm definitely doing is that I very, very carefully pay attention to whether there is any new LinkedIn post of yours. Similarly to 150k people that are also following you for very good reasons that the content that you're providing is very helpful. And at the same time, I think that the last message from us both for today, for the listeners, would be to motivate folks to actually think about the favorite framework of theirs, open source framework, and then consider to do the pull request for the contributors.
Yeah. I also think, yeah, since you mentioned that, I think GitHub is probably the coolest social media platform these days. It's, you do something productive and write some code, and I just enjoy it. I coded before I got into ML, and ML is just such a cool field because it's both. It's like math and coding together. It's an exciting time. AI is, developing so fast. I mean, while we are recording this, there was Grok 3, Claude 3.7, Gemini, so and so. DeepSeek announced they have their week of open source. They announced releasing the R2 model so like earlier than planned, and there's so much stuff happening. It's crazy, but it is an exciting time if you take it as like, hey, this is actually an opportunity rather than, oh, this is something that is overwhelming. I think getting the best out of it. It's important to also not get stressed about things, because it's easy to get stressed about things. It's maybe easy to say because it feels overwhelming. But sometimes, like I mentioned, I go offline and read my papers. And sometimes I just also turn off the Wi-Fi and get some work done without AI. It's finding the balance, which is important nowadays, because I think it's an exciting time, but also it doesn't mean you have to be on top of everything all the time. It's just having fun is my message.
Yeah. I can see what you mean. And I'm pretty sure that would be a good relief for people listening to us. Thanks a lot for your time, Sebastian. It was my pleasure to have you on the AI Catcher podcast.
Yeah, thanks so much for the invitation. And I really liked our chat. It was a lot of cool stuff we covered. And thank you for taking the time to ask me so many interesting questions and being so patient with my long-winded answers. Thank you.
AI Catch-Up brings the news. Tech solutions users can't refuse. Twice a month, it's all right here. AI products with human care.